Most people assume hydrogen infrastructure is the barrier to clean transportation. For trains, it isn't. Locomotives don't go everywhere. They follow fixed corridors, the same routes, the same terminals, day after day. And that single fact changes the entire engineering equation. When you know exactly where a locomotive travels, you can engineer the refueling infrastructure to match. Hydrogen at terminal points along a fixed corridor is not a network problem. It is a civil engineering problem, and the rail industry has been solving those for 200 years. That's what separates rail from every other hydrogen transportation application. Rail is one of the highest duty cycle transportation applications that exists. Locomotives run long hours, move enormous loads, and burn significant fuel doing it. High duty cycle means high fuel consumption, and that means the operational cost savings from switching to hydrogen are significant, not marginal. That's what makes the economics work for rail operators evaluating the transition. Diesel locomotives operating in tunnels, urban corridors, and rail yards produce exhaust and particulate matter that creates real air quality and regulatory pressure. That pressure is increasing. Cities are tightening emissions standards around urban rail operations. Hydrogen eliminates combustion emissions at the point of use, delivering direct operational and regulatory value to every operator running diesel equipment in an emissions-sensitive environment. Hydrogen locomotives are not a future concept. Alstom's Coradia iLint has been in commercial passenger service in Germany since 2018. It has operated across 8 European countries and traveled more than 220,000 kilometers on hydrogen power. In 2023, a demonstration project in Quebec carried more than 10,000 passengers over 130 trips. The fixed corridor advantage is already proven in real operating conditions. Rail fits the same engineering profile that makes hydrogen work in underground mining, ocean-going vessels, and factory forklifts, captive operation, predictable refueling points, high-duty cycles, enclosed or emissions-sensitive environments. When those four conditions are present, hydrogen is not an experiment. It is an engineering solution. If you want the full technical picture, the engineering, the chemistry, and the real-world performance data behind hydrogen and rail, and 3 other industries already using it, it's in my book, The Zero Emissions Engine is Here. The link is below. I'm David Jollymore. I've worked in hydrogen technology for over 20 years. This is what the industry actually looks like from the inside.